I wanted to give a quick note about our vocabulary. This is stuff we're going to keep talking about for the rest of the term. So just to avoid confusion, I want to be clear about what I mean by all of these terms right now. To begin with, we're going to have a random variable y, and the data that comes out of y when we sample it are the yi's. Here's 4, 2, 1. Those are the yi's, and we're going to refer to y as our dependent variable. It's the outcome. So we're trying to predict. What the data generating process is what we're trying to describe. So that's our dependent variable. And we'll also have another random variable x, and the sample that we get from x is our xi's. I'll usually refer to xi as the explanatory variable, but you'll also see it as the independent variable. I like explanatory. And then we have these two parameters, beta naught and beta 1, and that's the intercept and the slope. When we put hats on those parameters, that refers to the estimate of the intercept or the estimate of the slope. So beta naught hat and beta 1 hat is the estimate of the intercept and the estimate of the slope. Another part of the true model is the reason why all the data points are not going to usually fall directly on one line is that there's a disturbance term, what I'll call U. And that's always going to be unobserved to us. There's some unobserved reason that all of the data points don't fall on a line. So I'll say unobservable term or disturbance. Unobserved. So, y, x, beta naught, beta 1, u, these all determine what we call the true model here. And then we also have our estimated. Our estimated model is yi is beta naught hat plus beta 1 hat. And instead of a u, I'm going to say ei here. So how would I? To keep it really different. And this is a big focus in the class, the difference between u and e. E is our estimate of u, but E is something we call our residuals. And our residuals are manufactured from the OLS process. When we use OLS to fit this line of best fit, the residuals are manufactured because, whoa, that wasn't even linear. So the residuals are the vertical distances here, from here to here, here to here, and here to here. What EI is depends very heavily on how we pick this line of best fit. If we pick the line of best fit out here, then our residuals would be much larger. That's not a line of best fit. The line of best fit is defined by minimizing those residuals. And then, importantly, the residuals are the vertical distances because we don't care about predicting X. We want to predict our outcome variable, which is y. So we care about, let's say, for this X, we want this data point on the line of best